I would like to preface this video by reminding ourselves that constant velocity means no acceleration. Now let's see what happens when we have acceleration. So let's say we have an object that is speeding up and moving away from the origin. Think of a race, maybe like a 200-meter race on the track. So we'll have an object that starts at the origin and then accelerates. The graph will look something like that. In this class, the only graph that can have a curve will be the position time graph. Okay? Now let me show you how to know if that's speeding up or slowing down. So what I tell my students is pick 3 points and then draw a tangent line, that is a line that touches the graph at one point and one point only, and see if the slope is increasing or decreasing. For instance, if I pick this point here and I draw a tangent line, and then I pick this point here and I draw a tangent line, and then here, same thing, you can see how the slope is increasing. It's kind of flat, steepness increases, and then it gets a very large slope. The slope is increasing. That means the velocity is changing, is getting bigger, which means the object is accelerating. That's the way in which you can know if the object is accelerating or not. All right, let's draw the corresponding velocity time graph. We just said that the velocity is increasing. That should tell you we'll have a positive slope. Okay? We started from the origin at 0 position, so let's assume we started at 0 velocity, and we'll just have a line with a slope right there. So the velocity is increasing as time passes by. As you can see, the vertical component is going upward as time passes by. So this is increasing positive velocity. Let's say the slope of this line is 2. Well, the slope represents the rate of change, and that rate of change is acceleration. So the slope of this line of a velocity time graph represents the acceleration. Let me say that one more time. The slope of a velocity time graph represents the acceleration. So to draw the corresponding acceleration time graph, I just have to find where acceleration is 2. So let's say there. And there we have it. And we know this line is 2 meters per second squared. That is the acceleration. Let me just remind you, or not remind you because I haven't told you this, but let me tell you, for this class, we can only have straight lines. That means no slope for acceleration time graphs, okay? No slopes ever for acceleration time graphs. If you ever see a slope for one of these graphs represents jerk. So don't be a jerk, only lines with no slope for this class. And this is constant positive acceleration. All right, so now let's see what happens when an object slows down. Okay, we have an object slowing down and moving away from origin. That means the slope has to decrease because we have an object that is slowing down. So that means it'll look something like this. Let's do the tangent line test where you pick 3 points and see if the slope is in fact decreasing. So we'll pick a point here, draw a tangent line, more or less. Point here, kind of, sort of. Yeah, that one's better. You can see how the slope is decreasing. Very large number for the slope, so it's moving fast, slowing down even more. If it gets flat, that means the object stopped, okay? This one is not quite flat, but if we were to get flat, that means the object was slowing down at all times and then stopped. All right, let's draw the corresponding velocity time graph. We have that the object is moving away from origin. Now this one's kind of tricky, okay? Because some of you might say, oh, it's going to be negative velocity. But no, in this case, because we're moving away from the origin, we're moving positively. Because we're moving away from the origin, position is increasing, even though we're slowing down. This is decreasing positive velocity. Let's say we started maybe at this point. Now, I don't know if the object completely stopped. It almost stopped, right? Because it was almost flat. But I cannot assume it stopped, so I'm just going to say to this point. Okay? That is as much as I can say. If I had drawn the graph in such a way that it got completely flat, then I can reach 0 because that means there's no velocity. So I'm just going to say this is decreasing positive velocity. Okay. Now, the velocity is decreasing, so it has a negative slope. That means our acceleration will be negative. Good notes are telling me I misspelled acceleration. I don't think I did, but whatever. So we have negative velocity. So let's say the slope is, let's say 3, negative 3. So that means the acceleration is going to be negative 3 meters per second squared. So we'll find the value at which acceleration is negative 3, and we draw our graph. As we said before, for this class, we will only have constant acceleration. Positive or negative, constant nonetheless. Okay, now let's get into a kind of tricky one. I'm going to start now with the graph, okay? So we have an object, and the object is doing this. I want you to pause the video, and I want you to try to guess, what is the motion? Is the object slowing down, speeding up? What's happening? Try to do the 3-point test to find out. Stop the video. Okay. So first of all, the object is starting away from the origin and then going toward the origin. Okay, so it's moving backward. Now, if we do the 3-point test, let me change color because I already used blue. If we pick those 3 points, notice how the slope is increasing negatively. Almost flat, increasing negatively, more negative if you will, and even more so. So this is speeding up and moving toward origin. So speeding up negatively. I know that's a little confusing, but just do the 3-point test and you'll know based on the slope. Because the slope is increasing negatively, okay? Now, here I try to make the line be completely flat. Okay, so when we started, the object was completely still. That means the velocity starts at 0. Because it is increasing negatively, it has to increase along this line. And as you can see, this will be like -1, -2, and so forth. So that means it has to increase downward. That tells me I'm going to have a negative slope starting from the origin like this. And this is increasing negative velocity. Okay, pause the video again and try to draw the acceleration graph. Let's say this is a slope of -2 meters per second squared. Hopefully you saw that it'll simply be a line at which acceleration has a value of -2, and then just like that. Let's add those values just so we make that connection between the slope of the velocity time graph and the value for acceleration. There you go. And this is constant negative acceleration. I'd like to pause before we're going over the last graph. We can have two cases in which acceleration is negative. One of them is when the object is slowing down. The other one is when the object is speeding up but negatively. Okay, so direction plays a role. Again, you can have deceleration. So let's add deceleration here. And this one is accelerating but negatively. So both of those can mean negative acceleration. So be careful, okay? All right, last one. I'm going to again start with the graph, and then you guys tell me, well, you guys write down what is it that happened. I hope you tried the 3-point test and you saw that the slopes are decreasing. That means the object is slowing down and moving toward the origin. So slowing down negatively. Because the object is slowing down, the slope has to decrease. That means the velocity has to decrease, and it has to decrease negatively. So what that means is we will start at some point here, right? Because let's say it started at a very high speed, so maybe like 5 meters per second here. And then it goes to 0, okay? So we'll start somewhere here and then go like that. Because as you move vertically like this, you approach 0, okay? So the graph will look something like this. And we can say this is decreasing negative velocity. Now I want you to try sketching the corresponding acceleration time graph on your own. Now let's say this is a an acceleration. That means the slope is, let's say 3.5. meters per second squared. Give it a try. Hopefully you saw that because the slope is positive, your graph should be positive at a point where acceleration, is 3.5 meters per second squared. And we just draw a straight line with no slope. And this is constant positive acceleration. All right, class, now you have all the graphs we'll use in their simplest forms. Of course, we'll combine motions. Your quest homework has somewhat complicated graphs, but if you know how to read a graph and you know how to draw the corresponding ones, that is, you can go from position to velocity, velocity to acceleration, or backward, you are good.